Alright, CNT120, we are looking at Chapter 4 on Network Infrastructure and Documentation. Alright, our objective really is in this chapter to understand about commercial cabling or cabling in a commercial building and look at some of the diagrams and other things that go along with it, along with some of the documentation we do based on all this. So that's what we're going to be focusing on. Alright, before we tackle commercial wiring in a building, we have to kind of start with where we are now or what we know now. So real quickly, if you remember in the last chapter we talked about your home network, the Linksys Belkin gear router that you have sitting on your computer desk or next to your TV. That is really a little network in a box, if you remember. I like to get you thinking, how do you handle your cabling in your house? Well, most of us probably have only a couple things plugged into it, just a couple devices like desktop PC, printer, Xbox kind of thing plugged into it, and chances are it's just through a patch cable. Might be a long patch cable, you got a 20-footer that goes from one side of the room to the other that plugs in. But the point here is, because I only have a couple cables, because it's a relatively small room, if you will, I can get by using a couple patch cables. That works in a home or maybe even a small office setting, but it's not going to work in a large commercial building. Think about maybe the high school you came from, or some of the classes, your classrooms or buildings you sit in when you take classes on campus at HAC. So how we have to think now is, let's change our brain for just a minute. How do we handle power distribution in your house? Well, here's a little diagram of a house, and I think you can figure out very quickly by looking at it. These orange lines are really the power lines coming from the power company, going into electric meter on the side of the house, probably going into the basement or garage, into a circuit breaker box, and from there, electrical wires go up through walls and into outlets that we have distributed around rooms of my house. And the idea is, I have distributed power to my building, to my house, in distinct locations, allowing me to take a device like my toaster in my kitchen and plug it into this outlet, or no, I'm going to plug it into this outlet over here because I want to make my bagel over here at the kitchen table. This allows me to tap into that power where I like, but in an organized manner, an organized, safe manner. And really, if I wanted to, this will be bizarre, I could take the toaster upstairs to my bedroom, put it on the nightstand next to my bed, plug it in, and make a bagel in my bedroom, because there is a power outlet up in my bedroom. Okay, that sounds weird, but that is how we handle power distribution in house. It's organized, it's safe, and everything is kind of standard. The plugs are all standard that I can do, that I can take my toaster around my house, plug it in different rooms, and make my bagels or my toast. Okay? Well, we do that for just the reasons I mentioned, organization and safety, if you will. Well, if I try to take this method of dealing with data cables and use it in a large commercial building, it'd be like stringing, if I applied the same logic in a commercial building for data, I'd be stringing long patch cables across a room and down the hall. That doesn't work. So what I actually have to do in a commercial building is apply this logic with my data. So what happens is, in a commercial building, I actually have closets where my data cables leave and go out to computers or I should say out to rooms that allow my computers to plug into. So if I really wanted to, I could take my computer and wander to another room where there's data outlet, plug in, and have data connection. So to do that, I apply the same logic. I have, the ISP connection come in, and then I run data outlets all over the house so that I can plug into it where I want. That is how we handle data in a commercial building. We bring the ISP connection into the basement down here, if you will, into some switches. The switches then have a series of cables that go out to the rooms, and I put data outlets in all my rooms that way I can take a computer, plug in, and get a network or internet connection. And that allows me to, again, like I have the electric outlets in my house, move around and plug into it wherever I need. I can take my computer and go into different rooms and plug it in and have internet connection. And all of that is done in kind of a safe, organized, standard manner that I can do that. I can wander around and plug in my computer wherever I need, or, you know, in my office I could move the computer to the other side of the wall, plug my patch cable in over there, and I still have internet connection because I moved my desk over there. That is how, you know, this method in my home with patch cables is okay, but when I need to scale up to a school building or a hospital or something like that, I apply the logic I use on my power system. I apply that same logic using for my data system. So that's how we handle data in a commercial building using this type of infrastructure. Hopefully that gets your brain organized right, because otherwise when you start reading this, you're like, why do we do this? Why do we need this? Is why we do this. We need to organize all of our data so that I can have outlet boxes scattered around my floors for my computers to plug in and get internet connection, if you will. But it needs to be in an organized manner. So we do the closets on each floor, run cabling out to data boxes, if you will. Same logic as my power cords or my power system. So to do that, I literally do have a closet that I have a rack in with a patch panel. We'll get to that in a minute. And my cabling goes out, it goes up above the ceiling, down the hall, down the wall into an outlet box. And this allows the computer to use a short little cable and plug into it as they need, or unplug and move to another part of the room or another room and then plug in and have data connection. That is how that's done. And all this gets standardized so that this does work by using the 568 standard, which we'll get to in just a second. The other drawing I have here is trying to show you if I have a multi-floor building, what it looks like. I have a closet here on this floor, running cabling out to outlet boxes. I run a backbone cable, fiber cable to the floor above, and I repeat the exact same thing on the floor above. That is my basic structure, and that's what this is really trying to show you, the same idea. I have a bunch of different pictures, so hopefully one of these are clicking for you. That's why I have a couple different pictures. Well, to do that so that everything will work, I can take my computer from this room to this room to this room and have it plug in and work. Things need to be standardized. That was done by a group, a standards organization, EIA 568. That's the name of the standard, to design a standard way to do this that I can go from room to room to room. Standard cabling practices, standard outlet jack, standard pinouts on all my cabling, that it works no matter where I go. And this is called structured cabling. And again, this is needed in a commercial building, not necessarily in my house, but in a commercial building I need this. And this describes the best way to do it. Again, it does not matter. It doesn't matter the brands of things I'm using, as long as I do it all the same method with using the same type of jack and the same pinout, things should work. Things should work. This is a hierarchy design, like we said back here. Actually, I showed you back here, where I have a structure to it from floor to floor, but things are repeated. That is your 568 standard. There have been revisions over the years. The latest one is the 568C standard around the 2014 time frame, and there is actually sub pieces to it: C0, C1, C2, C3 on generic cabling, commercial building, telecom, copper, and fiber. There's actually pieces to this to describe specifics of each of these pieces of your cabling system, just as a little side note. And I know the book does not go into that detail. I'm just giving you an idea. All right, so that's the beginning part, just kind of getting your brain organized. Now we'll start working our way into, they mentioned a number of different components that you have in a commercial building. So we'll start working our way through these different pieces. The first one they mention is your entrance facilities and your DMARC. So let's take a look. Your entrance facility is where the incoming network, such as the internet, from your ISP, if you will, connects with a school or corporate network. So where that connection comes in from your provider, whether it be a Comcast Business or Verizon Business or whoever it happens to be, where that connection comes in, that is your entrance facilities. And in there is typically a device that plugs into that marks where the service provider network ends and yours begins, and that is called the DMARC. That's kind of where, that's almost like a fence, if you will. You know, on this side of the fence, the provider is responsible. The other side of the fence, we're responsible for connections, fixing, etc. Okay, so the picture they show you is a ISP connection coming into this closet, and there's the demarc device. Everything else is our responsibility to connect, maintain, repair, upgrade, etc. And that would be if you have a multi-building campus. You know, think about a connection coming into Wildwood and then connecting Blocker and Hall Tech and Whitaker and all those buildings. These would be the different buildings that I'm connecting together. If I have I think the next one I have here is a multi-floor building. If I have a multi-floor building, the entrance facility is probably going to be on the first floor basement, and that would be my entrance facility, and then I have multiple floors on top of that. Here's the other picture I showed you showing the entrance facility coming in. There's the ISP connection, the green one, and the demarc device is probably that one right there in the rack that they connect. Their connection comes in, and then we go from there. Here's another one I have that I found. Again, use any of these pictures you want to kind of get yourself sorted out. Here's another entrance facility. There's the ISP connection coming in. That would be where their responsibility ends, and the rest is our responsibility. A demarc device might look as something as simple as this. This is actually like a Verizon Fios box, if you will. But this could be your business connection that you have, and this would be where their responsibility ends and yours begins. Anything on the other side of that box would be our responsibility, something of that nature. So there's the entrance facility in demarc. Chances are that entrance facility in demarc is also at located in the MDF, main distribution frame. This is your main data closet, also called a main cross connect. There is only one per building. And this is that centralized point where LAN and WAN connections probably all come together. And this could also be a data room where you might actually have servers and wireless controllers and IP phone servers and things like that. It could also contain all of those things. Very common to have that. And that main distribution frame is, chances are, your main closet in the building. Probably first floor basement kind of deal. Here it is down here, and this is even trying to show you a rack of equipment and probably a phone server or server of some sort back there sitting. Same thing here. Here's our entrance facility, and there's a couple racks, probably a couple servers in there, maybe a phone server kind of deal. That's your entrance, or that's your main distribution frame. Might even look like this: a couple racks of equipment, a couple racks of cabling. Could even be as large as this. Now this is actually a server room, but this could be my main distribution frame too. Rows and rows and racks of server, depending on how large my facility is. Here's another one here, a couple main switches, some phone equipment on the wall. Again, this could take various forms. Here's another one with, here's a bunch of electrical panels on the wall and a bunch of racks of servers are ready for servers to be mounted in them. And again, here's a whole bunch more racks of servers and things ready to roll. So it could take many different forms, your MDF, your main distribution frame. The other type of closet I have in a building or campus would be an intermediate distribution frame, IDF. This is a intermediate connection between the main closet and the end user. So this is the middle piece. So the end user gear comes into this closet, and what comes out of this closet is the connections back to the main distribution frame. Could be, I need to have at least one per floor, but I could have multiple on a floor or multiple on a building, depending on what's going on, depending on the size of the building. So here would be my second closet in my building. My main distribution frame was down here. Here's my intermediate distribution frame on the second floor. And this would be an intermediate, and this would be an intermediate up here on this one. I think I just circled one, but the third floor would also be that as well. Here is another example. If I have a multi-floor building, there's some more IDFs up here. And again, its job is to take the connection coming from the main distribution frame and split it out to the users on that floor. Split out to the users on that floor. That is the job of that. And this would take, it would look like a smaller data closet than we looked at before. Some racks of connections, maybe a couple switches in there. A couple patch panels for all the cabling to come in and get organized and terminated too. Okay, and my user connections coming in, getting terminated to these patch panels. And it would probably look like this: some racks of patch panels and switches. That's about it. I'm not going to have a whole heck of a lot more in my IDF. There might be a server, might be a controller, but not near like the main distribution frame. It could even be as small as a little rack mounted on a wall. It does not have to be very large. Okay. In the next one, we'll come back and continue on with our next our additional components here.